Hey everyone, this is Reshma from Edureka, and in today's session we'll be learning about OpenStack Neutron, which is a networking service in OpenStack. But before I begin, I want to confirm from all of you if you all can hear me properly. If you can, then drop me a confirmation on the chat window, please. Okay, so Virat says yes, Jason says yes. Great, so let's get started. So this is what you should be expecting from today's tutorial on Neutron. So these are the topics. At first, we'll take a look at what is OpenStack and the OpenStack architecture. Then we'll see OpenStack Neutron. This is what the entire tutorial is focused on today. And then we'll take a deep dive into Neutron. We'll create networks with Neutron, and then we'll associate floating IPs to the VMs that we created, and we'll try to remotely access those instances or VMs. So this is what we'll be learning today. Any questions on that? All right then. So let us jump on to what is OpenStack. So OpenStack is a set of software tools that helps you to create your own cloud infrastructure. It is open source and a lot of companies are contributing onto OpenStack. So these are some of the few companies that have been contributing code to OpenStack. It has a very huge community, and since it is open source, it is said that open source technologies are actually going to be the future of cloud computing. So OpenStack is the only open source thing available in the market right now that helps you to create your own cloud. And you can set up either a public cloud or a private cloud with OpenStack. So this enables you to do a lot of things. So in today's tutorial, we'll be learning about how it enables networking service. Any questions about OpenStack? No questions? So now let us take a look at the OpenStack architecture and let us try to see where does Neutron actually fits in. So this is the OpenStack architecture. So this over here, keystone, is the identity service. So this implements authentication of users and authorization of a particular user. This checks the credential of a particular user and checks what other services that user is authorized to use. So Horizon is the dashboard. So with Horizon, you can actually have an overview of everything. You can have an overview of the computing resources that you're using. So that you can see in Nova, this is the compute service. This is where all the instances get launched. Glance is the image service. Swift is for storage. This is particularly for object storage. Neutron, this is what we're going to be learning today. This is the networking service. The Neutron enables all the different services to communicate with one another. Cinder is also for storage, but this is a pluggable kind of storage which is known as block storage. So heat is required when, let's say, that you have to set up different regions and you want to orchestrate and manage those different regions together. So this is when you use heat for orchestration. Ceilometer is used for billing purposes to have an overview of what services you are using, for how much time you are using. So this can come in handy when you are a cloud provider to actually bill your customers depending upon the usage or services that they consumed. And also if you just want to see and you want to monitor the services that you've been using, so you can use Ceilometer for that also. So this is the overall OpenStack architecture. Any questions? All right, you can ask me questions whenever you have any doubts. Even if you start thinking about this particular site and don't understand anything, even though I've jumped onto a different topic, you can still ask me. That's okay. So in the meantime, I'll move on right now. So now let us take a look at OpenStack Neutron. So this is the networking service of OpenStack, and it provides you with network as a service, which is known as NAS. So with Neutron, your instances can connect to a network. You can define networks using OpenStack Neutron. And Neutron was actually not the name when it was initially created. It was known as Quantum. And this service was actually released during the Folsom release, and then it was known as Quantum. And in the Havana release, the name changed into Neutron. And this was due to some kind of a trademark conflict, so they changed the name from Quantum to Neutron. But the question is that why did they ever introduce this networking service? Because already for the instances and the VMs, there was Nova Compute, right? There was certain amount of problems. There were layer 2 boundary limitations. and there were VLAN limitations also, because they were using the 802.1q standard, which actually allowed the VLANs to name from just 1 to 4094, 4094. So you could only have limited amount of VLANs. So that's why, to avoid all of this, to solve all of this problem, OpenStack Neutron was introduced. And this was actually a standalone core project, and it was created only because they wanted a completely separated software defined networking stack for the OpenStack ecosystem. And over here you can see this is how Neutron is laid out. So there is an API, there is the Neutron network. You can connect, so it can listen to different ports. You can define ports to which it will listen to, and every request will come. The Neutron router and security groups. So what are security groups? They are actually just a named collection of network access rules that are used to limit the types of traffic that has access to the instances. So you can define different security groups. You can define different ports in the security groups to the one which it will listen to. So you can see this architecture, and generally we actually use port 22 to get all those API requests. And the Neutron API does that. It gets all kind of API requests and it routes them to different components like plugin agents that Neutron has. So this is just a brief introduction to Neutron. Any questions still in your mind? Okay, so the network service in Horizon, which is the dashboard that I just told you, so it looks something like this. So you can find the network tab over here, and you can actually visualize the network topology that you've created. You can create networks over here. So you can create routers also. So we'll be doing that in a while. So this is how it is going to actually look like. Now let us take a look at some of the Neutron features. So the first thing is that Neutron is scalable. Since I told you with Nova Compute there were scalability limitations, since Neutron is now a standalone service which is used for networking, it has actually enabled scalability. Because in Neutron you can define nodes. So there will be a Neutron networking node deployed within our modular framework. And there are 3 agents that actually run. They are called the plugin agent, and that's the specific plugin based on the provider hardware or even the software. And there is also a layer 3 agent and a DHCP agent in order to deploy IP and DHCP services into the area. So with Neutron, you can actually create thousands of nodes. It is API driven. Now, all of the services actually communicate with Neutron with API requests. There's an API request. The Neutron API gets that request and it performs all the different tasks, and it also sends messages through APIs. So even communicating with different services altogether has become very easy. It is pluggable. It has the ability to logically separate provisioning and tenant networks. And I'll tell you that Neutron actually come with handy plugins. So it already has different plugins for Cisco, Open vSwitch, which is actually compatible with everyone. And the last feature is that it provides you with a very rich topology. Because when you use Horizon and you go to the networking section, you can see that it is very easy to visualize it. You can understand and get a whole picture of your entire network topology at once. And you can also edit the structure of your network topology while you are visualizing it. So these are the features of Neutron. So now let us understand Neutron in a better way. Let us create networks. Let us create VMs and assign networks to those VMs. So let's get started. So this is what our network layout is going to look like. We're going to have 2 networks. This is one network and this is another network. So there are VMs connected to this network, and there will be other VMs created to the second network. But you can see right now that these 2 networks are not connected together, right? So these 2 VMs can communicate with each other. Blue one can communicate with blue 2. Red one can communicate with the red 2. But red and blue cannot communicate with each other since the network are not connected. So I'll tell you how to connect different networks, how to create different networks right now. So I have an OpenStack setup ready in my system. So I'll just go there and I'll show you how to do that. So this is my OpenStack dashboard. So in front of you is the brief overview of the resources that I have used. So it is showing that I have used 4 volumes, maybe because of the previous instances that I created earlier. There are no instances launched right now, 0 vCPUs used. I have not used any RAM. So none of the instances, because there aren't any instances, so I haven't used any of the floating IPs. So there is one security group defined. So the first thing I'm going to do is create networks. So I'll go to the network tab over here, click on networks, and I'm going to click this button over here, create network. So you have to provide a network name for it. Let me just call it BlueNet. Make sure that you click this checkbox, create subnet, because you're going to create instances, and I'm going to create 2 instances, which is going to be assigned to BlueNet. So I'll click on next. So subnet name, let it be blue SN. So for net, you also have to provide with the network address. And there it is. So this is how you create networks. So I'm going to go ahead and create another network. So I'm going to name it RedNet. So the network address is something like 192.168.2.0 / the CIDR notation. So you can keep the gateway IP empty for now and click on next. And don't bother about filling out these. Just go ahead and click on create. So there it is. So I've got the blue net and the red net that I have created just now, and this is my public net, which was already defined. So these are the networks that I have. So I'm going to go ahead and create instances now. So for that, I'll go to compute over here, go to instances, and click on launch instance. So the first instance, I'll call it blue. The availability zone will be Nova, and I'm going to launch 2 instances. So I'll increase the count to 2. Click on next. So you have to select a boot source. So I'm going to boot my instance from an image. So the image is selected. And here are the images that are available in my Glance repository. So there is the Cirrus image. So I'm going to go ahead and select that. Now click on next. And you have to choose flavors now. So I'm going to go ahead and click on M1 Tiny. So this will have 1 vCPU, 512 MBs of RAM. Total disk size would be 1 GB. Root disk is 1 GB. So I'm going to go ahead and create 2 M1 Tiny images. Now you have to go to networks and assign network to the VMs. So I'm going to assign the blue net that we have just created. So select that and click on launch instance. So there it is, the 2 instances are launched. So similarly, I'm going to create 2 more instances naming red, and I'm going to assign it to the red network. So let's go ahead and do it. So the instance name would be red. So again, I'm going to launch 2 instances. Click on next, boot from image. I'm going to use the same Cirrus image, and I'm going to use the same flavor as well. Now for network, I'm going to assign the red net and click on launch instance. So these are the 4 instances that we have just launched. So blue 1 and blue 2 are assigned to the blue network, and red 1 and red 2 are assigned to the red network. So these are the IP addresses of the instances that we launched. So I'll just go ahead and I'll try to ping these instances from blue 1. So click on blue 1, go to console. So log in, so the username is Cirrus, password is given to you. So there it is. So I'll try to ping blue. So this is the console of blue 1. So I'm going to go ahead and try to ping blue 2 from blue 1. So the IP address of blue 2 is 192.168.1.8. And you can see it is able to reach blue 1. Now let's try to ping red 1 from blue 1. So the IP address of red 1 is 192.168.2.11. Now you can see that it is unable to ping red 1. Why is that? Because these two networks are not connected together. Let me show you the network topology now so that you can understand it. Go to Networks and click on Network Topology. So you can see this is the blue net and I've got two instances, blue 1 and blue 2. And this is my red network. We have got two instances, red 1 and red 2. If you want to see the graph, click on Toggle Labels. So you can see that blue net and red net are not connected together. So this VM cannot ping any of these two VMs because they are not connected. Even they are not connected to the public network as well. So in order to make that connection, what we need to do is we need to add a router. So we'll go to the Routers tab over here, click on that, click on Create Router. So name your router, so I'm just going to name it Router 1. So don't worry about the other options here, the admin state is already up. So go ahead and create this router. So the Router 1 was successfully created. Now let us go back to the network topology and let us check what changes actually happened. So now you can see that there is a router, but it is not connected to any of the networks. So for that, you need to go to Routers. So if you want to connect two networks together, we use a router. And in the router, we need to add interfaces. So click on the router over here, go to Interfaces, select this button over here, Add Interface. So you have to select a subnet. So at first I'm going to select the blue net. So this is optional, you can leave it blank and click on Submit. Similarly, I'm going to add one more interface to connect the red network. Select the red network now, click on Submit. Now let us go back to the network topology to see what changes actually took place. You can see now that the router has connected the red network and the blue network together. So now let us go back to our VM and try to ping red 2 from blue 1, which was unsuccessful before. So go to Compute, Instances. So this is the console of blue 1. So now let us try to ping red 1 from here. So remember the IP address, it was 192.168.2.11. This is red 1. We're trying to ping red 1 now. And you can see it is successful. It is because we have connected these two networks using the router. Now let's go back to the network topology again. You can see that these two networks are not connected to the public network yet. So in order to do that, we go back again to the router. So go ahead and add one more interface. Select the public net this time and click on Submit. So now if you see the network topology again, you can see that the router is connected to the public network now. So now if you want to access any of these virtual machines from any other source, from outside your cloud infrastructure, you have to assign floating IPs to each of the VMs. So let's go back to the instances. So go to the option over here and you can find this option, Associate Floating IPs. So click on that and click on Allocate IP. Click on Associate. So floating IPs are nothing but these are unique IDs given to each of the VMs in a network so that anyone can access them. So we'll go ahead and click on Associate. So if you see that there are no ports available, you need to go and add rules. So let me show you how to do that before assigning floating IPs. So go to Access and Security. So click on this button over here, Manage Rules. Click on Add Rule. And in the port section here, add 22 and click on Add. So after adding the rule, you can go back to Routers and click on Select Gateway. So you have to select a network and select the public network and click on Submit. And you can see a gateway interface has been added. So if you go to network topology, you can see that all the three networks, the public, the blue, and the red, are connected via the router. So now you can go ahead and associate floating IPs to each of your VMs. So go to Instances. So now we'll go ahead and associate floating IPs to each of my VMs. So click on the Associate Floating IP option. Select an IP address. So click on any of that. Port to be associated, this is red2, so let it be red2, and click on Associate. So this is the floating IP that has been associated to red2. And similarly, you can associate floating IPs to the other three VMs as well. Now with the help of floating IP, I'll be able to access red2 from an external network as well. And similarly, after assigning floating IPs to the other three VMs, I'll be able to access them too. So after you've assigned floating IPs, you can connect to the public internet. So there will be outbound traffic going to the public network, and you can also receive inbound traffic as well to your instances. So this is how you can use Neutron for networking to connect your instances that you have created in your OpenStack infrastructure to the public network. So any questions, guys? No questions? So this was all about Neutron. So a brief summary of what we have learned today. So we have learned what is OpenStack and the OpenStack architecture to find out where Neutron actually fits in. We have learned about OpenStack Neutron and how it enables networking as a service in OpenStack. We have created networks and associate floating IPs so that we can also remotely access the VMs or the instances that we created in Nova. So this is what we learned today. So thank you guys for joining today's session. I hope you have all enjoyed this tutorial and you learned about OpenStack Neutron. If you have any queries or any questions or any feedback that you want to give me, kindly leave it on the comment section below. And I'll see you next time. Till then, happy learning.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!